for commercial line. Naramata Station 161, first medical response.
This is the first of several videos for pumping with Engine 163 covering the topic of quick water. In the video, we will look at engaging the pump upon arrival, starting flow to a hand line, switching over to a hydrant, and finally concluding operations. When arriving on scene, the operator ensures that there are no overhead electrical hazards. Then the operator selects neutral, applies the parking brake, and honks once to let the members know they can exit the apparatus. After double checking the transmission is in neutral and the parking brake is set, the transfer switch is moved in two stages. First to the middle position, which releases the air pressure from the road side of the selector, and then, after a few seconds, to the pump position, which moves the gear selector to the pump position. Then the operator shifts to drive to engage the pump. A rising speedometer confirms the transfer. The operator now safely exits the apparatus. Chocks the tires and begins circulating water by opening both the tank to pump and tank fill valves. These two valves are located in these positions on the pump panel. It is important to open these two valves to allow water to circulate, which will keep the pump cool. In the final step in engaging the pump, the operator must press the green mode button on the throttle controller to pick from one of two modes to control the pump, either RPM or pressure regulation. Most operators prefer to start in RPM mode, which will require a couple of presses of the mode button. In this setting, the throttle controller will maintain whatever RPM is set by the operator. In the next phase of the evolution, a firefighter will prepare an attack line for charging. There are a number of pre-connected hoses on Engine 163, including a bumper pre-connect. Regardless of the line selected, it's crucial for the firefighter to remove all of the hose from the hose bay. When ready, the firefighter and pump operator may signal that they are ready for water and confirm that water is on its way, either over the radio or through clear, line-of-sight hand signals. The pump operator can now open the appropriate discharge valve. The tank fill valve should now be closed to better allow the pump to develop pressure. The throttle controller is now used to increase the RPM set point. The large pressure gauge on the right, labeled pressure, allows the operator to clearly see the output pump pressure. For our 1.5-inch attack lines, a good first target is 100 psi. We will be assuming no friction losses for this training video. The large compound gauge on the left displays the pressure at the input of the pump, which will always show 0 when pumping from the tank. At this point, we're pumping from the tank with 0 psi entering the pump, 100 psi leaving the pump, and the engine is operating in RPM mode at 1100 RPM. The operator may be tasked with supplying water to additional discharges while still pumping from the tank. When ready, simply open the required discharge and make any RPM set point changes necessary to continue to hit the 100 psi target. With the additional line flowing, simply use the increase-decrease buttons to adjust the RPM. Although things are stable at the pump panel, the tank is quickly running out of water. The next phase in the evolution requires switching the pump supply from the tank to a hydrant. The operator can now leave the pump panel and find and break the next coupling in the supply line. There are two locations to connect the 4-inch supply line. In a later video, we will look at connecting to the rear suction, but in this video, the operator is using the main suction at the pump panel. Remove the cap, connect the supply line, and test the connection to ensure that it is correctly locked in place, and the hose is flaked out in a straight approach to the truck. With the supply line securely connected and the air bleed opened, the hydrant operator can be signaled to send water. It is not uncommon for the pressure relief valve to briefly discharge water when the line first fills. This is normal. Currently, the RPM of the engine is well over 1000 RPM, and the pump operator is now ready to carefully transition to the hydrant supply. To help make a smooth transition, toggle the throttle controller into PSI mode. The following transition is important and requires practice and some background knowledge. To better understand the transition, let's take a moment to imagine what would happen if it is done poorly, where the operator only opens the main suction valve. While the tank delivers water at 0 psi, the hydrant delivers water at a higher pressure, and this will be evident on the compound pressure gauge which monitors the input pump pressure. Since the throttle controller is in PSI regulation, it will respond to the increase in pump output pressure by lowering the engine RPM. The controller, however, can only lower the engine speed to a minimum of 750 RPM. Even at idle, the pump will add to the pressure from the hydrant and create an output pressure, displayed on the main discharge pressure gauge, that would exceed the safe limits for the handlines. One method of dealing with this extra pressure is to transition to this scenario here, where the tank fill valve is partially opened. This large diversion of water will reduce the residual hydrant pressure, shown on the compound gauge, to the point where the discharge pressure at the output of the pump will be the targeted 100 psi. Again, the transition requires practice and will follow these steps. Simultaneously, the operator now 1. Slowly opens the main suction valve, 2. Visually monitors the output pressure of the pump, and 3. Avoids pressure bumps by opening the tank fill valve to divert water to the tank. A careful operator can keep the output pressure very close to 100 psi and begin the process of refilling the tank. At 750 RPM, the minimum, we're able to keep the output pressure at 100 psi only because we're filling the tank. But at some point the tank will be full and we'll have to close the tank fill valve. This transition also requires some practice. When the tank is full, closing the tank fill valve will result in an increase in pump discharge pressure. To protect the firefighters on the handline, their individual discharge valve can be slightly closed, or crimped down as we say, in order to hit a targeted pressure. All handlines will require individual adjustments, and as a comparison we will not crimp down the 2.5-inch handline in the following clip, and you can see that its pressure will rise significantly. As the operator closes the tank fill valve, they monitor the discharge output pressure and crimp the discharge valve down to maintain 100 psi. Notice the pump output pressure rises to close to 200 psi. This is expected and unavoidable. We now have about 130 psi entering the pump and about 180 leaving, but we're able to keep about 100 psi at the tip of the nozzle by crimping the bumper discharge valve down. You may see a warning on the throttle controller indicating that it can't lower the RPM anymore. As an operator, don't be surprised that if the attack line stops flowing water, the crimped valve will not reduce the pressure, and the operator will see the discharge pressure temporarily rise, but then fall again as water flows. If you are concerned that the pump may overheat if no handlines are flowing water, you can slightly open the tank fill valve to allow a small amount of water to flow. Only a small amount of water is needed, so open the tank fill valve just enough to see a small reduction in the discharge pressure. Another option is to open the pump cooler valve. This also allows some water to flow back into the tank. When firefighting operations are concluded, the operator can set the throttle to idle by using the red idle button and close all valves, including the tank to pump valve. It is our department's best practice that the operator must be sitting in the seat when they make changes to gear selection or the transfer switch. After selecting neutral, watch and wait for the speedometer to drop to 0 as the drive shaft comes to a stop. Then, move the transfer switch first to the middle position and wait several seconds before moving the switch all the way into the road position.